Welcome to EduAmp. This is a Year 10 lesson, GCSE physics, and it's all about movement and speed. And what I'd like you to be able to do at the end of this lesson, explain the difference between distance and displacement, use speed equation including changing units and rearranging the equation, and explain the motion of a circle in terms of speed and velocity, and describe an experiment to measure the speed of sound. So first off is the difference between distance and displacement. So I want to imagine here you are at school, well, going to school rather. Here's your house, lovely house, and you've got to go to school here. And as you walk to school, you take a wiggly path, go and see some friends, go to the shop, whatever it is, but your path is never going to be straight. And here you go, you arrive at your school. And yeah, they can travel, let's say, about 700 meters. Now, we call that a distance. And the reason why we call it distance because it only has a size. That's how far you travelled. The posh word for a size we use is a magnitude. Now, also what I can do is I can draw it in something called a vector form. Now, what I'm going to do now is I'm going to draw a line. And say you start in your house here and you go all the way to over here. I could then draw a perfect straight line like this. Now that straight line, maybe for example, only could be 500 meters. Then what I could do is I can take the line here and I can say the angle is going to be 60 degrees. Now, as soon as I do that and draw that line, I can say it's going to be 500 meters and I'm going to say it's 60 degrees from the point here. I'm going to have the angle. You can choose whatever point, reference point you want to. Now, as soon as I do that, this is now changed to a displacement. And the reason why it's changed to displacement, because now it has got size and direction. Hence then, that going through here, we've now got the 500 meters 60 degrees. And that's the difference. Displacement has got size and it's got direction. And we call this a scalar quantity, and this is going to be a vector quantity. Hence, we use this, for example, if we got robots trying to position them somewhere like a Mars, whatever it is, and we have got robots on Mars now, and we can actually give them a vector, therefore it follows this line here, and we can tell exactly where to go and what direction. If we're just giving this distance, it's telling us nowhere what direction to go to, and we can use this for robots. Now, armed with that then, is you need to know how we calculate speed. Well, speed is a straightforward, dead easy equation. And speed is simply equal to distance divided by time. Now, there are different formula sheets. Some of you will see it written down like this. And it's an equation I'm afraid you have to learn where V is going to be the speed, S stands for distance, bizarrely enough, and T is going to be in time. Now, if you measure your distance in meters and you measure your time in seconds, it means then your velocity is going to be meters per second. You also can measure your distance in kilometers and can measure your time in hours, which means then your units come up as kilometers per hour. So it can come in different units. Now, a classic example where we use this is the dreaded speed camera. Now, when you drive along the road here, and this could be a 30 mile per hour speed limit, whatever it is, you'll find you've got all these white lines along here. Now, I'm drawing in black, but these lines are roughly about 1 meter apart. Now, if you have noticed in a speed camera, what happens is, as you approach the speed camera, you first of all, when you're here, you get a flash. It takes a picture of you. And then about a second later, or it should be bang on a second, you get a second flash. What that allows them to do is work out your speed because they literally look at how many lines you've gone through to work out your distance, and they know the time is going to be 1 second. And what they can do then is they can actually calculate then how far you traveled with time. Therefore, what they can do is they can work out your speed, and that's why I need 2 pictures. Now, these are quite evil, and they are very effective, but they only get your speed at this point here. you may notice now on the motorway, we start seeing an average speed camera. Well, these are different. They again use the equation of speed equals distance divided by time, but now they use a much larger distance. Now, this distance could be about 2,000 meters, and then they could work out wherever your time is. Say, example, it's going to be 20 seconds, which works out then you're traveling very fast, 100 meters per second. What happens then is they do a much, much larger distance all the way along here, about 2 kilometers, and really it works out your average speed from point A to point B, which could be, example, 2,000 meters. Hence, your speed can change in between as you travel between A and B, and what it does is work out the average speed. The reckon's a lot better because it controls your speed a lot bigger distance. But in theory, you can go in very, very fast, speeding, and then slow down, and therefore your average speed can be absolutely fine. But that's the difference between them. Now, what you have to do then is be able to use the equation to actually calculate these. And this sort of example you can get hold of where you're changing from units to kilometers per hour to meters per second. So you've got a train travels at 340 kilometers per hour in 4 hours. What's its average speed in meters per second? Well, what you need to do is use the technique I've always on about. Use speed is simply equal to your distance divided by your time. And the techniques we're using are formula, working, answer, units. Tick, you got your formula in. Now, there are different ways to tackle this, but I can say, right, if it's doing 340, it's a bit of a misleading question. All you need to do is write down, first of all, its distance, but you've got to convert this by knowing 340 kilometers is then equal to 340,000 meters. So your distance is going to be 340,000 on here. Now, if it's doing that, it means it's going to travel 340,000 meters in 1 hour. But you've got to put your time into seconds because I want this in meters per second. So first of all, I've done my distance in meters and I need my time in seconds. I'm going to go for 1 hour. Well, you know 1 hour is going to be 60 times 60. You've got 60 seconds in a minute and you've got 60 seconds in 1 minute and you've got 60 minutes in 1 hour. Then that leaves you is going to be 3, 4, 1, 2, 3. And then we all know that's going to be 3600 here. And you bung that in your calculator and you pop up with 94.4 meters per second. You could use the 4 hours. And in the 4 hours, what you can do is you would then have 340,000. You multiply by 4, the total distance is going to travel. But then your time would be 60. Multiply by 60 you had before, but then also multiply by 4 because you've got 4 hours. And all what happens, the 4s cancel and you end up with the same bit here. But you'll meet these sort of questions, and that's basically they're asking you to change the units from kilometers per hour to meters per second. Okay, the last little bit I want to show you here is all to do with circular motion. Now, I've got quite a bizarre simulation here, but it does work very nicely. Now, what I want to do is get away with that one. Here, you've got 2 bugs, a nice little ladybird here, and you've got a green bug here. Now, this green bug basically can move in any direction you want, but suddenly when it starts to move, can you see a green arrow starting to appear? This is because this is a velocity vector. Now, if you move it forwards, can you see a green arrow starts going that way? Because you've got to show the velocity but in a certain direction. The length of the arrow shows you the size. Therefore, we move slow. Can you see the arrow is quite small? But if I move big, the arrow is big. Longer arrow shows a bigger velocity. And I move it down, the direction shows me direction of velocity. Hence, velocity is another vector quantity, a bit like displacement. Now, what I've got here, a nice little ladybird. Now, what I can do is make this little ladybird start to go around like, go around like this, and it will start to move. Now, as it starts to move going around like this, I thought I'd do it manually, going through here, it will start to rotate. Now, I'm now going to make it rotate at a constant speed going round. Now, yes, you're probably getting a bit dizzy here. Now, if I pause it, it's going around in an anti-clockwise direction. Here you can see the arrow going along here, directing like this, and it's pointing this way. Now, that then, the size of the arrow is staying the same because it's going at a constant speed. Remember, the length of the arrow shows the size of the vector. Therefore, it's going at 3 meters per second. The length of the arrow must remain the same. But can you see here is pointing in that direction? When I go up here, it's pointing in this direction. When I go over here, it's now pointing in that direction. Can you see the velocity vector is constantly changing direction? Now, this is a very important concept because now, if I quickly sketch roughly a circle going around like this, what you've got here is you've got, and I'll change the colour here, you've got a little ball that's going around like this. Now, if I did my velocity vector, it's going that direction here as v. When it gets to that point here, it's going down v here, and as going over here, it's going to v going over there. The velocity vector is constantly changing direction. And this leads to a concept where you must have something called acceleration. Now, it's the next equation we're going to do in our videos. Acceleration means a change in velocity. And the equation we write down is we write down a delta v over t. Now, what this means is a change in velocity. In other words, acceleration is velocity changing with time. And believe it or not, something going around a circle, going around like this here, because its velocity is constantly changing direction, you've got to have acceleration, even though its speed could be constant and 3 meters per second. And that's all linked in circular motion. Okay, so I'll leave a link to this in the video as well. This is how you can measure the speed of sound. And it's a nice little practical, and what you can do is you make a clapping sound here, and the sound waves go all the way out here, they hit a wall, and they reflect back. And what you can do by using the equation again, that speed equals distance divided by time, you can basically have a distance to the wall, you time how long it takes the sound to reflect back, and what you can do is measure the speed of sound. But I'll leave that link there for you, and you can look at it for yourself and see how you do it. So, to go with that then, I've just covered, is the difference between distance and displacement. I've told you the speed equation, and you've done changing units and rearranging the equation. We then explained the motion of a circle in terms of speed and velocity, and I'm going to leave you a link to measuring the speed of sound.